Not yet? Okay, here we go. All right, so they are asking us to start on time. People will probably continue to trickle in, but let's get started. So hi, everyone. Welcome again to gRPConf, and thank you all for coming out today. Glad you could all make it. My name is Doug Fawley. I am the tech lead for gRPC Go, and today I'm joined by Lucio Franco, who's the owner of Tonic, which is the leading implementation of gRPC in Rust. And so today, we are excited to announce that we've been working together for the past few months on a new gRPC implementation in Rust together. So I'm sure we have some people here today who are experienced Rust developers already, but probably a lot of people in the audience aren't very familiar with the language. So before we get started, I wanted to talk a little bit about Rust itself and its growing popularity. At last year's gRPC conference, we received a lot of questions from developers, both on stage and off stage, about supporting Rust. And that was really the first time that we started to strongly consider a Rust implementation. Also, recently, the Linux kernel and the Android open source project added support for developing in Rust. And that's a really great advancement for the language. And this is part of a wider industry trend. A lot of projects are migrating to Rust or allowing Rust in their project. And lastly, the Rust community is really growing fast. In a survey that was done last year, over 3 million developers, or 12% of all developers, were using Rust, which is triple what it was 2 years prior. And also in 2023, a Stack Overflow survey was done and declared that Rust was the most admired language, which meant that 85% of people that used it wanted to continue using it in the future for their work. And this was the highest among all languages that they surveyed. And as you can see, so on Reddit, r/Rust recently surpassed the Go subreddit's subscriber count. So to talk a little bit more about Rust, though, I wanted to hand over to Lucio.
All right, thank you. So why Rust? Well, consider these three things: performance, reliability, and productivity. Most languages make you pick two of these. Rust lets you pick all three. Rust has the ultimate performance. It offers low-level control of your software, has no built-in runtime, so there's no GC pauses, keeping your tail latencies pretty low, and this means predictable performance for your latency-sensitive applications. In addition, Rust has great reliability. It has a strong type system that can detect many bugs while you're writing the code. It's memory safe. Has great built-in language rules like move semantics that are not built in a lot of languages, but Rust has chosen to make them built-in. And it has borrow checking, which is a very famous part of the language, prevents race conditions and other things that are common in multi-threaded code. All this is checked free by the compiler. Finally, productivity. Rust provides great error messages, making it really easy to use the language. Its language server helps you effortlessly write code. It has an easy-to-use build tool called Cargo, and its toolchain installer RustUp is also extremely easy to use. And because of a strong type system and great tooling, refactoring your code is super easy and can be done at 3 in the morning with no sleep. Now, a little bit of history about gRPC and Rust. Before 2019, there were two main projects. One was a pure Rust implementation that was incomplete and had some performance issues, and the other one just wrapped the C++ implementations. For users that wanted a pure Rust gRPC implementation that was production ready, there was no option, and this is where Tonic was born. Tonic's goals were to support the new async await syntax, and be written in pure Rust, and to also be production ready. In addition, the Tonic project was created by the Tokyo project maintainers with the goal of supporting Tokyo out of the box and its ecosystem. In 2024, Tonic has become the most popular gRPC implementation in Rust with over 64 million downloads. Tonic by itself only implements the gRPC spec, but does not do any of the protobuf encoding. This is where Prost comes into play. Prost provides a pure Rust implementation of the protobuf spec. It is designed to be ergonomic for Rust users. For example, it works directly with Rust structs, and it even provides a derive macro that allows you to implement protobuf encoding and decoding on pre-existing structs. Tonic and Prost are great, but they do have some limitations. Tonic was never designed for complex gRPC use cases, but instead was targeted to get people started with Rust and writing distributed systems in gRPC. Due to this, there are some feature gaps in its implementation. Some examples for Tonic that it does not support are service configs, which enable services to configure client behavior. As well, it does not have advanced name resolution and configurable load balancing, no dynamic connection management, and does not support XDS for proxyless service meshes. Like Tonic, Pros intentionally has some deviations from the protobuf spec in order to be as Rust idiomatic and ergonomic as possible. Some examples of this include lack of support for non-zero field defaults, no preservation of unknown fields when reserializing, and in Pros accessing nested unset messages can be a little bit tricky. Most of these trade-offs are fine for most Rust users intending to use gRPC at a basic level, but fall short for larger consumers of gRPC that need the whole feature set. This is the goal of the new gRPC Rust implementation, to bridge the gap between what Tonic currently has with what the other mature gRPC implementations provide. Now I'll turn things back over to Doug to talk more about the gRPC Rust project.
All right, thank you. All right, so given the limitations that Lucio discussed, we're starting a new implementation of gRPC in Rust with the goal to provide a great Rust experience and all the features provided by the other languages that we support. Upon release, this will be available using the gRPC crate name. And I wanted to say thank you to Stepan Koltsov, who had the name, control over this name before and transferred it over to us for this project. gRPC Rust will be entirely open source, and it will be fully supported by the gRPC project under the CNCF, just like all of our other languages. It will have the full set of gRPC features, including all of the things Lucio mentioned were missing from Tonic, and interceptors, observability, health checking, retry, and more. Like Tonic, gRPC Rust will be a pure Rust implementation. Design started earlier this year. Implementation will begin soon, and we expect to release a version next year. And so we're also excited to announce the release of Google's protobuf Rust library, which will be coming later this year. This will also be available on crates.io using the protobuf crate name. And Stepan Koltsov actually had that name before as well and donated that to Google for the official project. Protobuf Rust will be a first-class, Google-maintained implementation, just like we have for Java, C++, Python, and other implementations. It will fully conform to the protobuf specification. And it's actually already in use within Google, and it will be used extensively by Google going forward. It will also have the same level of support and release schedule as other supported languages. And in the future, if Google products offer any APIs or SDKs that use protobuf for Rust, then this is the crate that we will use for those. For most open source users, we expect that protobuf Rust will be the default option, but it is possible that Prost may be a better fit for some use cases. And just like gRPC and other languages, gRPC Rust will be usable with any serialization, including non-protobuf-based serialization, or protobuf Rust, or Prost, or any serialization of your choice. And lastly, I'm happy to announce that the first release will be coming later this year. So going forward, some of you may be wondering what will happen to Tonic and Prost. So Tonic and Prost are considered to be mature and stable and suitable for production, but no new features are planned for them. gRPC Rust will provide a new channel and server implementation, and it's not designed to be a drop-in replacement for Tonic. However, we will try to reuse as many Tonic abstractions as possible, and the goal is to fit nicely into the Rust ecosystem, similar to how Tonic was envisioned. And to make the migration easiest, we will provide a guide to help existing users of Tonic migrate to gRPC Rust. Tonic itself will be upstreamed into the CNCF project. It will be moved to the gRPC GitHub repo, and it will be managed by our team. Exact details are to be determined as design and implementation continue, but this is the plan. So to recap and also give some rough milestones on the work that we're doing, the design and prototype for gRPC Rust has already started. Implementation will begin soon. There's already a proof of concept that's been done, but it's very much incomplete. But official implementation will begin soon, and that will occur in the Tonic repo. So if you're looking for information or to see updates, that would be the place to find that. Basic channel and server implementations are expected to be available for testing mainly in early 2025, with a stable 1.0 release expected late next year. And for XDS support, that's a bigger undertaking, and so that'll be coming in the following year. So that is the end of the content that we had planned today. Hopefully y'all learned about what we're working on and have some questions. So please feel free to ask now, or you can find us later in the halls.
Thank you for the talk. I just have one question. Once you finish this work, is there a reason for gRPC C++ to exist? Like, can you just wrap that again? Yeah.
It's an interesting question. So definitely there are visions in our heads about how we can take all of the great benefits that Rust give us, bundle it inside of a C++ wrapper, and provide this same benefit to C++ programmers. That is so far in the future that we have no official plans for that yet, but it's certainly something that we've entertained the idea of. It would need to be either API compatible or it would require a migration, and so there are those considerations as well. But yeah, good question, thank you.
And my question is about Rust itself. I'm new to Rust, and so memory leak kind of crash is the two main pain point when we develop C++ based server, right? So in the Rust, in the slides you mentioned there are no GC. Does that mean there's still application level need to handle all the leaking, handle all this crashing somewhere? How that get handled?
Yeah, so Rust itself doesn't prevent it's still possible to leak, but the main concept is that the language itself, as long as you don't use the unsafe escape hatches that are provided, what you're writing will statically deallocate itself at the end of scope. So it uses your classic scope bindings to control when to deallocate memory. But it provides tools to also go above and beyond, like reference counting and things like you might know available to you like in C++, like unique pointer and shared pointer. Those are things that are built into the standard library that provide you tools to kind of control the memory. So in theory with Rust, as long as you're not dereferencing pointers manually and you're using the constructs that are provided for you, you're not going to have any null pointer dereference issues or memory leaks, though it is still possible in some cases to create memory leaks, but in most basic uses of code, things will get deallocated at the end of the scope or manage, dereference count or whatever that is. It depends what type of crashes you're talking about. I mean, like if it's a dereferencing of a pointer, which I would imagine is the most common sort of like seg fault style crashing, that's basically never going to happen in Rust. I'm putting a quotation mark on that because it's still possible, and we do wrap purely unsafe C-style code with abstractions, and it's possible to have a bug in that. But in general, your code won't crash for pointer-style dereferencing things. Now, Rust doesn't prevent you from, having a branch in your code that you didn't expect, and for your code to blow up. That is still possible. But with the type system and the borrow checking, you kind of prevent a lot of those very common and frustrating kind of crashes where you don't know where they're coming from, mainly seg faults, because usually seg faults don't provide you a line of where it blew up. So Rust prevents those things for sure.
Just a quick follow-up. So when we trade off the Java plus with C++ server, right? So one big benefit for Java is if one RPC request come in, when the server handle that, this RPC something through some random exception, this can be caught in the server and handled in this request, and other requests can leave untouched, right? So for Rust, do we get the same benefits for the in the gRPC stack?
Yeah, so on top of the memory safety, right, we prevent those entire error cases. There's kind of two different error paths that Rust provide. One is your traditional error handling, which I think is what you're talking about, right? Let's say, there's some handleable error that comes from an RPC call. You get that returned to you without a crashing. You could basically get a result object return that either returns something that is okay, like a valid RPC response, or an error. And then the other error path is a panic, which is kind of like your unhandled exception path that you might have in Java. There's no such thing as try, catch, and Rust. There is a way to kind of catch a panic, but that's done at like the system level to catch, like, oh, I did not expect this panic to go off. But 99% of errors that you would want to handle come through the return type in Rust. It's an enum essentially that returns, either successful or false. And so you're always forced to handle that as well.
Great. Could we talk a little bit about the protobuf feature set that you expect to support? So I took a look at Prost and also Rust protobuf, and there were a couple things that I'm hoping you can confirm will be addressed. One you mentioned was support for missing fields. I think the Prost developer said, I'm not going to do that at all. So there was that one. Maybe you could comment on that, and then I'll ask you about the other one.
Yeah, we could.
Yeah, if you want to talk about what the Google protobuf Rust has, yeah, that will be supported. Basically, the goal of the Google implementation is to fully conform to the spec and behave exactly like it does in the other major languages. So, yeah, all of the behavior around, if there's an unset field, like dealing with the default value being non-zero, if there's unknown fields, those will get reserialized. So if you put them back on the wire, they'll come unchanged. These are things that aren't done in Prost. In terms of Prost, changing what it supports, I think that like what we have now with Prost is what we're going to end up with. And unless there's a bug that needs fixing or something like that.
Right. So I'm not
maybe
really
you're considering this more of a bug.
Yeah, I'm not expecting anything new to come to Prost, but it's more about the Google protobuf implementation. So what this means is that if I have a protobuf that has some known fields in my handler, it gets a message that has unknown fields. They'll go someplace. They'll be loaded into some structure that I could then read to see the dynamics.
Right. Yeah. Unfortunately, nobody from the Google protobuf team could make it here to the conference. Otherwise, I would refer you to them. I'm just sort of delivering the announcement message from them. So I'm not sure on this particular one. I have looked at their API a decent amount, but I don't recall offhand the exact answer to that. I believe there should be some way to access the unknown fields.
So the other thing that I really struggled with was JSON serialization of protobuf messages, which is easy in the other languages, and it's just really difficult in Rust. So is that something that's going to be built in, or would I have to add an option to get that with Rust protobuf?
I guess similar to the other question, I honestly haven't heard about that one. But I mean, you can certainly reach out to the protobuf team, and if you're not getting a reply from them, you can let me know. But through their GitHub repo, I think you can create an issue and ask questions like that.
I will say that for Google internal usage, unknown field support is a hard requirement. I learned that lesson 8 years ago. Not to any surprise to me, but certainly a surprise to people. So you have confidence there will be a good story there. JSON is a space I pay less attention to, but unknown fields absolutely is one.
Yeah, but I think having worked in client libraries and things for Google APIs, JSON support was really important, and so I would be very surprised if it wasn't, but it'd be nice to hear that it is.
Yeah, I mean, the goal of the protobuf Rust project is to make protobuf accessible in Rust for Google to use internally. And so any use cases that are important for the other languages should be important for Rust as well. And so I would be surprised to hear that any of these things aren't
Yeah, I
done the
think-
same way as C++ does.
I think you sort of hinted that if Google ever offered client libraries for Rust, they would be based on this.
Right, they'll be using protobuf Rust. Google's client
Yeah.
libraries will use protobuf Rust instead of Prost, yes.
Now?
Yes.
Yeah, my question. So we have quite, our org has quite a few use cases for like usage of Tonic and both Prost. Do you know what the migration story is going to look like here if, assuming that Tonic and Prost are going to be kind of phased out as it's being taken over by Google?
So definitely the answer is that we don't know yet because we haven't gotten there yet. But we have some vision, or at least I have some vision on how, the project is going to grow up in this sense. Well, first I'll talk about Tonic. Like Tonic and Prost, I don't think are going to be deprecated. I don't like that term. It's going to be still supported. It's going to still be an option for users. So I don't expect that will just disappear off the plate. Migration-wise, the goal for this new implementation is that like most of the code that you touch or that you have available to yourself will still be usable. Granted, now, as long as we don't find any major issues or fundamental problems, which we're still currently in the phase of exploring, which is why I can't tell you for sure. But if everything goes to plan, the idea is that it should almost not be drop-in, but everything you touch mostly as a user should be workable and still continue to work. And what will happen is the like deep level, low level implementation details will kind of completely change, right? And that's not something that you should worry about because the API kind of already encapsulates most of that. So like I would like to say that the migration will be pretty painless. Like the vision that I have, it should be pretty simple, but again, like there's still a lot of unknowns to uncover, and gRPC seems simple, but there's a lot of complexities under the hood, especially when we get into stuff like load balancing and XDS, which is the reason it doesn't exist currently in Tonic is because it's highly complicated. And so, we might uncover things as we go, but the goal will be to make it as painless as possible and the migration as simple as possible. So that way, users like you that, already are using pretty heavily Tonic and Prost shouldn't have that much of a migration. Now, I think there might be more pain point migrating from Prost to the new protobuf Rust, I suspect. That is definitely going to bleed more into your code. And I have not I've not seen the protobuf Rust code yet. But knowing some of the limitations of Prost and some of the design goal differences, I suspect that is going to probably be the larger pain point. But again, I think in general, that code is pretty isolated and it shouldn't be too bad as long as it doesn't leak everywhere. So I think that's the most that we know right now. And definitely in the next few months, as we get towards the implementation side of things, we will definitely uncover what that will look like. So,
Right, yeah, I have seen the APIs from protobuf Rust, and they are substantially different because in Prost, you directly access the fields of a struct in order to get the message data. But in protobuf Rust, they'll be behind accessors instead. So it's going to look very different. Do we have time for more questions?
I think we
No?
take one more.
Okay.
And then we might need to move the discussion onto the hallway.
Okay.
To make sure that people can get in for the next talk.
Yeah, so we can do one more, but then feel free to just find Lucio or I later.
It's my turn.
Okay, go ahead.
Yeah, so I just wanted to know, is Rust a approved language inside Google for developing applications?
So
and,
Rust, oh, sorry, go ahead.
And the second part is how many people in Google or outside Google are staffed for this entire effort, gRPC and protobuf?
Okay, so inside of Google, Rust is kind of conditionally, like experimentally approved right now. So we are using it, but not very widely yet. In terms of this project, at this exact moment, it's essentially Lucio is helping me do some design, and I'm splitting my time between Go and Rust. But we expect to be staffing up and actually doing real implementation with 2 or 3 people working on this in the near future, like as soon as next quarter potentially. But yeah, some of those details are TBD.
Oh, sorry.
Go ahead.
I was going to add, we're doing the planning for next year. So this is definitely one of the top priorities that we want to invest in more. for, the next few years.
Okay, all right. Well, thank you everyone for coming. Enjoy the rest of your day.